Right, hello. I did indicate last time that, you go up there, that I'll be talking about some of the other bits and pieces found on page 33 in terms of the words used in statistics. Jumping straight in, I used the word hypothesis last time. Hypothesis. When we talked about the data handling cycle, stage one was to ask such questions that you wanted to investigate, and this question would lead to a hypothesis or an idea which you wanted to investigate. So hypothesis is just a Greek word that means an idea, a notion. So that's what it means, and that's how you use it. That's a nice sciencey or mathsy kind of word, hypothesis. All right. Once you start collecting data or bits of numerical information, the data can be raw data. In other words, it's unprocessed. You've not done any calculations yet. You've not put it into tally charts. You've not put it into tables. You've done nothing at all. And the raw data you collect is primary. In other words, you've collected it, primary data. You've collected it yourself. It's original. You won't find it anywhere else, anywhere. Not like those particular sets of data that you have collected. It's all yours, and it's primary data. So it says here, primary data are data which are collected to investigate a hypothesis. So you get your primary data, it helps you answer whatever question or idea that you have regarding what your investigation. Secondary data is something different. Rub it out, going too quickly. Right. Secondary data. Right, what does that mean? Well, if, for example, you're researching something and you know you can get similar sorts of figures from maybe the internet or from a newspaper or from a journal or from a magazine, it can help to supplement the original primary data that you collect for yourself. So primary data is your own, it's raw, it's unprocessed in any way, and the secondary data can be found out from other people who investigated similar has similar lines of inquiry, and you may want to beef up your primary data and have secondary data alongside it, just to see if it provides any further light on your hypothesis. All right. So, hypothesis, your idea, the question you're investigating, raw data, unprocessed raw numbers. What you collect is primary data. What you can find out from yourself, from the internet or any other source, is secondary data. Now, data can be of two types. So if I put data here and put it into two types, we've got ourselves some quantitative data. Now look at the word, we've got the word quantity there. That implies numbers. Alright, so quantitative data, there is a numerical quality about it. And that's all there is to it. So for example, if I want to count the number of people entering a shop at 9 o'clock in the morning, just to see how many are entering at 9 o'clock in a supermarket, say, and then that will be a piece of quantitative data. Each person that walks in, it goes 1, 2, 3, 4, I count them, and there you go. And I have got better things to do, but that's an example of quantitative data. Another piece of data is called qualitative data. So for example, quantitative data does not involve numbers, but measures things like quality, for example, taste, colour, things that you don't necessarily put numbers to. So if I said to you, what do you think about eating pears, I can't really put a number on your response. All I can do is to write down your response, and that will be it. I can't say, you like eating pears, you love them, therefore that's worth 23%. It doesn't work that way. I just record your qualitative response, and that's what I've got. Alright, so data, quantitative, involving numbers, and qualitative, involving wider quantities that do not involve numbers at all. Alright, now, what else? If we have quantitative data, let me take it a little bit further, there's two types. There's discrete data, or discrete quantitative data, but it comes off the data branch here, so I must be talking about data, mustn't I? Discrete. Now these have a fixed whole number value. So again, if I'm counting number of people going to the supermarket, I'll get 1 person, 2 person, 3 people, etc, etc, etc. I won't get 2.63 people coming into the supermarket. Alright, so the number of people, the number of red buses that passed at the bottom of my road are whole numbers. Alright, so that's discrete. The other type of quantitative data is called continuous. Now, this does not have to be whole numbers. So for example, if you look at your height in centimeters, you do not have to be a complete whole number of centimeters. You may be 172.38946 centimeters tall, but even that won't be perfectly accurate. So things like height is a continuous measure. Another one is your weight. So for example, you may weigh 52 kilograms about, but actually you're more like 52.1639 or whatever kilograms. But there's no whole number cut-off point for weight, just there isn't a whole number cut-off point for height. The other one, of course, is height, weight, and of course things to do with time. Things don't have to take a whole number of minutes, a whole number of hours, or a whole number of seconds. So time is in fact another continuous variable, right? They're the three classics. So we could be talking about weight, kilograms, or grams, or whatever you want to do. Time, seconds, minutes, hours. Thing is, there's no whole number necessity for that type of piece of data. All right. So data, qualitative, e.g., colour, or taste, or loads of things really. What do you think of furry rabbits? Well, they're nice and cute and cuddly. I like them a lot. Oh, that sounds like a 93% to me. No, not at all. It's just a qualitative piece of information gathering that you can record as a response. Surveys, for example. Quantitative involves numbers. They can be discrete and they have to be whole number things, or continuous, such as height, weight, and time. Now, let's see what we've got over the page now. Yes, if you want to do some statistical investigations, you need to draw your information from, say, a population. Alright, so here's the population, the word population. It is a maths word. To draw from the population, you can't talk to absolutely everyone in the school, or everyone in the area, or everyone in the country, or the world, or the wider universe. In order to do an investigation, you need to get a sample from the particular population you're talking about. So let's have a look. Maybe my population might be my school. So your whole school population, it doesn't have to be the whole UK and all the rest of it. So if the population in my school, you can't talk to everyone in your school unless you've got a school about 30 or 40 children. But you can get a sample from kids in your school. And if you're in the senior school, you may want to talk to a sample from year 7, 8, 9, 10, 11. You can't ask all of them. You just take a selected number from each year group, for example. So how many from each year group? We don't need to get into a huge amount of detail, but just recognise that you don't speak to everyone, you speak to some from each year group, and that will be your sample. Let me try and define population for you. Talked about here loads of tyres. So here, if you can investigate tyres, for example, it says the population of tyres is all the tyres that are of the same type in the world, say, or in the UK. Now, you need to take a sample of these tyres and to do whatever investigation you want to do on them or whatever. So really a sample is just a small part of the population, and I'll write it just here for you. So a sample equals small part of the population. So that's about that. That's what that is, and that's fine. Clearly, if you want to draw a sample from a population, if the sample is too big, it's going to take an awful long time trying to question your rather large sample. If the sample is too small, you may not get sufficient data to make to give significant and meaningful conclusions. So, whilst you start your data handling cycle, you may have a valid question, but if you only speak to 4 people out of a school population of, say, excuse me, 1,500, you won't get sufficient feedback to get meaningful results. Your means will be far too inaccurate and unrepresentative of the whole school population, and so that's not going to be adequate. Alright, so I think I'm going to stop there. Not a very exciting video, not too mathsy, just lots and lots of words. Need you to read page 33 and 34 like I said in the previous video. Get it inside you and think about it yourself. Do some further reading. There's an example on page 34, and you know, at this level it's not too difficult, is it really? Learn the words,